So example 3 is asking us to multiply instead of add and subtract. We know this because look at the parentheses. Is there anything separating them? No, there's no sign in between the parentheses. That means that we want to multiply. So we have to be particularly careful here and make sure that we FOIL appropriately. So the first one, part A, gives us 3 plus 4i multiplied by 2 plus 7i. And when I distribute that out, I get 3 times 2 is 6. 3 times 7i is positive 21i. 4i times 2 is 8i. And I'm going to write that right under here so that I'll remember to combine the like terms before I'm finished. And finally, 4i times 7i is positive 28i squared. So there's a lot of cleanup that needs to be taken care of here. We have the 6 plus 29i, and then this guy right here, the 28i squared. What does that become? Negative 28. The I squared becomes negative 1, so really it's plus 28 times negative 1. But because of the order of operation, we have to multiply before we add and subtract. So this whole piece right here becomes minus 28. Be really careful with that. 6 plus 29i minus 28 for a grand total of negative 22 for the real part and positive 29i for the imaginary portion. Okay, part B. For part B, I'm going to distribute 5 minus 7i onto 1 plus 3i. So 5 times 1 is 5. 5 times positive 3i is positive 15i. Negative 7 times 1 is negative 7i. And negative 7i times positive 3i is negative 21i squared. So now we start combining like terms. We have 5 plus 8i. And negative 21i squared is really negative 21 times negative 1, which actually turns it into positive. Right. The I squared on the end here is always going to change the sign in front of that term. So it's going to be positive 21 for a total of 26 plus 8i. Now let's multiply negative 2 plus the square root of negative 16 by 4 minus the square root of negative 9. First thing you need to do is simplify those radicals. Do not leave those. Don't risk multiplying with those there. So go through right away and let's change that to negative 2 plus 4i times 4 minus 3i. Then we can start distributing it out and foiling it and cleaning it up. Simplify those radicals first so you don't make a mistake and leave your eyes off. So we have negative 2 times 4 is negative 8. Negative 2 times negative 3i is positive 6i. Positive 4i times positive 4 is positive 16i. And positive 4i times negative 3i is negative 12i squared. Before we go any further, what is negative 12i squared going to become in the next step?
Positive 12.
Positive 12. So please don't forget that. So now we have negative 8 plus 22i plus 12 for a total of positive 4 plus 22i. So we say the real part is 4 and the imaginary part is 22. 4 is little a and 22 is little b for this complex number.
Get square root of 5.
So here we want to talk about complex conjugates. The complex numbers a plus bi and a minus bi are called complex conjugates of each other. When we multiply conjugates together, radicals and i's disappear. So if we're looking at the problem 3 over 2 plus I, we're not allowed to have imaginary numbers in the denominator because technically they are irrational. Not only imaginary, but irrational because they contain radicals. So we have to come up with a plan for removing those from the denominator and moving any i's that are left into the numerator. And because it's a binomial, the only way to do that is to multiply by the conjugate. So if we look at 3 over 2 plus I, and we will multiply top and bottom by 2 minus I. And then we will distribute the top and the bottom. Sometimes it helps people to put parentheses around all of the binomials so they don't forget to distribute anything. So the 2 minus I, we just have to kind of make it up. The top distributes to 6 minus 3I. That's just a monomial multiplied by a binomial. So you just distribute the 3 to each of those terms. Now the denominator is a binomial times a binomial. And we need to multiply that out using FOIL. So we're going to multiply 2 by 2, 2 by negative I, and then we're kind of done with the 2, so we can move on to the I. If we multiply this positive I by 2, we get positive 2I. And then if I multiply positive I by negative I get negative I squared. The top has no like terms, so we're just kind of going to keep it and write it down again. We have 6 minus 3I over. Now in the denominator, what happens to negative 2I and positive 2I? They cancel to 0. That is what conjugates are supposed to do when you multiply them together. If that doesn't happen, you did something wrong. But that only works with conjugates. It doesn't work with any others multiplied together. But because they were conjugates, the 2 outer and inner terms should cancel to 0, leaving us with 4 minus I squared. Well, minus I squared really is minus negative 1. So that is really plus 1. So here we are now. We have 6 minus 3I over 5. Nothing will reduce. We have a 6, a 3, and a 5. And so we're just going to leave it because they don't have a common factor. However, it's not plus or minus, so that's not the issue. But I believe, if I'm not mistaken, for WebAssign, you're going to have to type it in like this. 6/5 minus 3/5 I. That's going to take some practice. Because WebAssign was causing so many glitches for people, I went in and I changed the number of times you can answer a problem from 3 to 5. I just upped it because there were too many little things going wrong, and I thought the 2 extra chances would help a lot. So if you have missed one in the past because you ran out of opportunities to enter a new answer, go back and try it again. You should have 2 extra shots. So be really careful, use those wisely, because I've decided I'm not going to override anymore. You've got 5 chances to get it right. If you don't get it within 3, come and see me, and let's see if maybe you're typing it in wrong, okay?